rational number. You need to prove that that is nothing but root 2 going to be irrational. To prove that, I start by taking it as rational number. Let's take root 2 is rational. Root 2 is rational means you can write this root 2 as equal to p by q. And now here p and q are coprimes. P and q are coprimes means here q is not equal to 0 and they don't have any common factor which is other than 1. Now let's prove that this is not rational and we're going to get it as irrational. That is contradictory method of proving it. Let's shift this q that side. It's going to become root 2q equal to p. Now square on either side. Here also do whole square and here also you do whole square. Root 2 square becomes 2 and q times of square becomes q square. Here p times of whole square becomes p square. Here let's take p as equal to 2k. Now you can write this one, that is 2q square equal to p square. You can write it as 2k whole square. Here 2k whole square means you can write it as 2q square equal to 2 square is 4 and k times of whole square is whole square. It is nothing but 2 times of q square. You can shift that to that side. Q square equal to 4k square by 2. 2 1 times 2 2 times is 4. So q square equal to 2k square. Now you know that here they are giving q square means 2 times of k square. Here 2 divides q square. If 2 divides q square, it must definitely divide any one of the number, just the number q. Also it must divide because p and q we taken as coprimes and they are whole numbers. So even each number it must divide. So it gives that 2 divides q. So q has a common factor which is 2. So q is not a coprime. This 2 divides q means p and q divides 2 means q is not coprime. Q and p and q are not coprimes means they both have any common factors, then other than 2 they are prime numbers and don't have any common factor like 2. So here 2 becomes the common factor, so they are not coprimes. So we take on that is root 2 is rational. That is wrong. Our assumption that root 2 is rational going to become wrong. So this root 2 is irrational number. Root 2 is irrational number. That is contradictory way of proving this thing. What is that? That is root 2 is rational or irrational number. In the same way you can even prove the root 3, root 5 minus root 3, 3 plus 2 root 5. Let's start by taking this time this circle. That is, if you take this circle, normally I going to tell how to find out area, perimeter and then sector of the circle. If you take this circle as radius 1 units, here radius is 1 units. Let's find out what's the perimeter of the circle. Perimeter of the circle can be written as 2 pi r. That means it is 2 times of pi times of this is the radius which is 1 units. You're going to get 2 times of 1 as 2, 2 times of pi it is 2 pi units, or you can again more simplify it as 2 times of 22 by 7. 2 times of 22 is 44. 44 by 7 units going to become the perimeter or known as circumference. Let's find out what's the area of the circle. Area of the circle you can find it out as like this, pi r square. This going to become pi times of this is the radius. So radius square it is 1 square. 1 square means nothing but 1 times of 1 which remains as 1. So this is pi times of 1. Pi times of 1 remains as pi square units, or you can write it as 22 by 7 square units. Now let's take a clock problem, or I going to tell how to find out area of this sector of a circle. If they have given a circle and they have given a little bit sector of this circle they are giving it out as 30-degree sector. In this 30-degree sector you need to find out area of this shaded area. That is this only this part 30-degree sector you need to find out. The radius they are giving out as 5 units. Here radius is 5 units. You need to find out area. Area of sector is theta by 360 times of pi r square. Here they are giving theta is equal to, let's write here, 30-degree. This is only 30-degree. You take out the pizza piece from this complete circle. Here theta you can write it as 30 by 360 times of pi times of radius is 5, so it is 5 square. Now you can divide this, divide 0 with 0, 3 1 times, 3 1 times 3, 3 2 times 6, 1 by 12. So it's going to become 1 by 12 times of pi times of 5 square means 5 times of 5, 5 times of 5 is 25. So this is going to become 25. This 25 times of 1 by 12, you can get it as 25 by 12 times of 12 pi square units, or you can again simplify it like this. That is 25 by 12 times of 22 by 7. That is 2 6 times, 2 11 times. 11 times of 25 is 275 by 6 times of 7, 42. That is the actual area of this sector of a circle. Now I'm going to tell how to find out the root of numbers there about the circles. Again this thing, you need to prove this number, that is root 3 is irrational number. You need to prove root 3 is irrational number. You can prove it by contradictory method. First let's take this one, that is root 3 as rational number. You need to take root 3 as rational. So you're going to get this root 3 as equal to P by Q, where P and Q are coprimes. Where P and Q are coprimes. P and Q are coprimes means they don't have any of the common factors. They are prime numbers. P and Q are prime numbers. So you're going to take P and Q as coprimes and they don't have any common factor between them. Now you can take this one, that is take Q here, that is root 3Q equal to P. Now square on either side. After squaring you're going to get, that is after squaring you're going to get in the same way you're going to get here, that is root 3Q whole square, and here P square. Here root 3Q whole square means it is root 3 times of square is 3 and Q times of square is Q square, and P square remains as P square. Now let's take P equal to 2K. P equal to 2K, if you take, you're going to get here 3Q square equal to 2K whole square. When you take like this 2K whole square, you're going to get 3Q square equal to 2 square is 4 and K times of square is K square. Here it is 3, so you must take it as 3k square. This 3k square going to become 3 times of square becomes 9. Now you can divide this 3 you can send this side, that is q square equal to 9k square by 3, 3 1 times, 3 3 times, q square equal to 3k square. Now you can see this 3 can divide q square, 3 divides q square, so this 3 can also divide q. Now you're going to get another one. Here they are giving 3 can divide even q. What it can divide? It can divide even the q. So this one you can write it as, what is our assumption that p and q are coprimes are wrong. Our assumption going to become wrong. Our assumption is wrong. So that it is root 3 is irrational. You're going to get root 3 as irrational number. We're going to tell next problem, that is about squares. Let's talk more about squares, how to find out area, perimeter and different things in it. If you take a square, I start to practice lot more problems here. All sides of this square are just 1 units. When side length is just 1 unit, you need to find what's the area of the square. You can find it out. Area of the square is equal to a square, That means it is 1 square. 1 square means 1 times of 1, which remains as 1. 1 square units is the area of the square, and perimeter of the square can be written as 4 times of side length a. That going to become 4 times of, here the side length is 1 units. 4 times of 1 is 4, so it is 4 units is the actual perimeter. Let's take one more square. In this square, they are giving out all the side lengths as 2 units. Here also, you need to find out what's the area and what's the perimeter of the square. You can do the same way. Area of the square can be written as a square. So this is going to become, the side length is 2 units. So it becomes 2 square. 2 square means 2 times of 2, which is 4. So it is 4 square units is the area of this square. Let's find out what's the perimeter. Perimeter is 4 times of side length. That going to become 4 times of, this is the side length, which is 2 units. 4 times of 2 is 8, so it's going to become 8 units. Let's take one more square. In this square, they are giving out like this, that is all sides of the square as 5 units. When all sides of the square going to become 5 units, you need to find out what's the perimeter of the square and area of the square. You can find it out. Area of the square is side length square a square, that going to become 5 square. 5 times of 5, which is 25. So this is going to become 25 square units. Now perimeter of the square can be written as like this, that is here 20, perimeter is 4 times of side length, that is 4 times of, this is the side length, which is 5 units. 4 times of 5 is 20, so this is going to become 20 units. Now let's take one more square, and in this square you can take it like this, that is here they have given this all sides of the square as 7 units. When all sides of the square are 7 units, you need to find out what's the area of the square and what's the perimeter of the square. Here also you can do it out. Area of the square as side length square a square, that going to become, here the side length, which is 7 units, so it becomes 7 square. 7 times of 7, which becomes 49. So this is nothing but equal to 49 square units. Now let's find out what's the perimeter of the square. Perimeter going to become 4 times of, this is the side length. So this is nothing but equal to 4 times of 7 unit. 4 times of 7 is 28. So here it going to become 28 units is the actual perimeter of this square. Now let's take one more square. And in this square, they have given all sides of the square as 10 units. When all sides of the square going to become 10 units, you need to find out what's the area and what's the perimeter of the square. Here the side length is 10 units. You can do it out. Area of the square as a square, that is here the side length is 10 units, so it becomes 10 square. 10 times of 10, which is 100, so this is going to become 100 square units. Let's find out what's the perimeter. Here the perimeter is 4 times of side length, so that going to become 4 times of, this is the side length, which is 10 units. 4 times of 10 is 40, so this is 40 units is the actual perimeter of this square. Now I'm going to tell the last problem, which is to prove that this thing root 3 root 5. Now I'm going to tell root 5 is irrational. You need to prove that root 5 is irrational. How to prove it out? Root 5 is irrational is the actual thing we need to prove. Now let's prove this one. To prove it, you can do like this. That is, let's take root 5 as rational. Root 5 as rational number. After taking that, you can take this root 5 as equal to p by q, where p and q are coprimes. Where p and q are coprimes means they don't have any common factor, they are prime numbers. And you need to find out you need to disprove that root 5 is rational. So take q that side, it going to become root 5 q equal to p, and afterwards let's square on either side. this root 5 square becomes 5. 5q square equal to p square. Now you're going to get this one. Let's take p equal to 5k. Now you're going to get this p, you need to write it as 5k. 5q square equal to 5k whole square. 5k whole square means you're going to get 5q square equal to 5 square means 25, and k square remains as k square. Now you can divide this 5 one times, 5 5 times, or you can send this 5 here, and afterwards you can divide 5 one times, 5 5 times. Q square equal to 5k square. 5 can divide q square. 5 can divide q square. So 5 can even divide 5 can divide q, because if it divides the q square, we took them as co-prime numbers, they don't have any common factor, so 5 can divide q. Now here they have given what is our assumption, that p and q are co-primes or lie. Our assumption is wrong. Our assumption is wrong. Our assumption is wrong. So p and q are, what is our assumption, that is root 5s rational, is also wrong. That is root 5 is irrational number. Root 5 is irrational number. That is the actual proof. Let's take the final problem like this. Here we can take the final problem. In this problem, I going to tell how to do this one. Here they give equilateral triangle. You need to find out area of this equilateral triangle. What is the area of this equilateral triangle? Area of equilateral triangle is root 3 by 4 times of a square. That is root 3 by 4 times of, here the side length is 1 unit, so it is 1 square. 1 times of 1 remains as 1, so it is root 3 by 4 square units is the area of this triangle. I continue after some time in next short. Bye.